Now we have understood about what databases are, what spatial databases are, and the types of features that we could actually define in a spatial database. We will talk specifically about marine features and the feature types, okay? So the first feature that we would like to know is the natural features, of course. So we've got ocean floor types. This is just the general idea of it. So you've got the continental shelf here, and then you've got a continental slope in which it basically, so these are in feet, okay? So it might be confusing for you who are used to metrics. Me too, because I was like, why are these numbers are very, very big? That's basically because it's in feet. So you've got your continental shelf, and then you've got your continental slope when you actually changing from a continental crust into an oceanic crust. You've got the abyssal plain in here. You've got some abyssal hills. Abyssal hills is just basically hills that are in the abyssal plain, so it's quite deep. You've got your seamounts, and then you've got your oceanic trenches, and then you've got some volcanic islands. So the idea in here is to identify, which type of spatial data are you going to represent them in. So I would say that these areas like shelf, continental slope, abyssal plain, you want to define them as lines or an area. Of course, because a continental shelf is continuous in in one area, so you want to know where the continental shelf ends. And then when your continental slope ends, you also want to know them in terms of lines or in terms of area. And your abyssal plain as well. So you either want to make them, oh, this area is abyssal plain, or you want to define where you start and where you end your abyssal plain. So if you think about it in 3D, it would be a continuous line instead of only like points. While in abyssal hills, it's either you can draw them as points if it's only points, if the hill is only like it has one summit. But if the summit is, because sometimes the abyssal hills look lengthened, so you can also define them as lines. But I don't think you can define them as area because they're not big enough. And then seamounts, normally you just define them as points because they, if it's seamounts, then they only have one summit instead of like abyssal hills. They could actually, oops, sorry. Yep. So seamounts normally it only look like this. So you can see them in 3D. So you only have one summit. But abyssal hill, sometimes it looks kind of like this, if you understand what I mean. So they are basically lengthened somehow. So you can actually draw them as lines as well. And then for oceanic trends, normally you draw them as lines. Why? We will talk about this later because this is basically, again, it's the same thing as this one. Yeah, you want to make them as continuous because I don't think there's an ocean trench that is only like one. Normally it's like a line. And then for volcanic islands, it depends on how big it is. If it's not that big, you can make it as a point, or if it's quite big, for example, Hawaii is a volcanic island, you can actually draw them as an area. So again, we're going to talk about the tectonic boundary. We have actually talked about this, yeah? So this one is actually the trench, okay? And you can see them in here, okay? So I will repeat it, it's basically here, yeah? So a trench is actually where the oceanic plate is going to be destroyed, basically. So they are destroyed because they've got more density than the continental plate. So those lines, that's basically why you want to draw them as lines instead of points or areas. So those are the oceanic trench. And then you've got the oceanic spreading ridge in the middle. Okay, so that's basically where you actually have the new oceanic crust created. And then you've got a transform boundary. So if you see here, there's actually like something like that, okay? Because it's actually when you've got oceanic spreading, you've got elevated seabed. And then you actually have somewhere in which they are actually moving towards each other, but they're not destroying each other, but they're not creating each other as well. So that's where actually your transform is. Why did I draw it like that? Because it's actually, it's a three-dimensional thing. So that's actually somewhere like behind that kind of mountainous area. So normally for tectonic boundaries, you draw them as lines. So this is how you actually present them. So either you can actually just put the names. So you've got Iceland basin in here. Okay, so that's actually the area, but you can actually just put it, in a name. So you don't put it in a point or in an area or something like that. You just have the same. So this is the Lousy Bank, for example. I don't know who named it. So you've got the Celtic Shelf in here. And then you've got the Porcupine Bank, you've got the Trough in here. So basically areas, you can just put the names on it. And there's actually a rise, there's a ridge, stuff like that. Or you can actually draw the lines as well. So for example, this is a subduction zone. Subduction zone is basically a trench. So the trench is actually subducting that way. And then you've got your transform faults in here. Okay, so that's lines as well. And these are your mid-oceanic ridges. So this is where your oceanic crust is created. So it's basically opening. Yeah. And then this is where it's not created nor destroyed, but they're actually moving towards each other because this one is, spreading, that one is spreading. Then there's actually a movement as a consequence of that spreading. And then there's actually where your plate is actually destroyed. So that's the subduction zone. Okay. So we want to know as well how the nautical features or the navigational features are represented. Okay, so you can see the representation in nautical chart number 1. So each country they publish their own nautical chart number 1 because they want to have it in their own language basically. And you can try to access the US nautical chart number 1 within this link. Okay, so for example, you can see, so they've got basically an index of A, B, C, D, E, F, G until Z. So for K, for example, they're talking about rocks, wrecks, obstructions, and aquaculture. This is already number 16 and 21, but you get the idea that this area, basically, this is how you draw your shipwreck, for example. This is the international part, but if you're drawing it for ECDIS or for the electronic chart, electronic nautical chart, you draw it just like this. So basically, because there are a lot of symbols that will be seen in a nautical chart, you need to have a standardized legend, for example. So for example, this legend, the nautical chart number 1 from the US, there is 137 pages, I think. So you can have a look at this, and basically all the way they represent the data must be the same, and it's actually standardized internationally. So you can actually compare your own nautical chart number 1, for example, in Indonesia or in India. You can compare it with the US, or I don't know, if you cannot access it, you can compare the US one with, for example, a Canadian one or with the French one or something like that. So that's how you represent your data in navigational features.